Okay, so here are some optimization problems. You can access this PDF on Blackboard. So number one, we have a farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river, so we want to figure out what are the dimensions of the field that has the largest area. So when you have optimization problems, what you're really looking for is the word maximum or minimum or largest or smallest. That's really what the keywords are. So if you really want to know the difference between optimization problems and related rate problems, that's literally what it is. So I want to go ahead and find the largest area. So I know that the area is equal to the length times the width. Okay, now notice that they didn't give us anything about area. I don't know what length and width is, because we want to figure that out. But I do have this 2,400. Now this 2,400 feet of fencing, well, if I have a river that is just straight, and then I want to figure out what is the maximum area. So my rectangular field is going to look something like that. I want to maximize this area, and I only have 2,400 feet of it. So this entire thing, all of this red part is just the 2,400. Now this is just not the area. This is going to be the perimeter. So the perimeter is equal to, well, in this case we have 2 lengths and 1 width. Okay, or you can just use 2 widths and 1 length, doesn't really matter. But so what we really have, we have 2 lengths plus 1 width, because we don't want to fence the river. That doesn't make sense. So we have 2,400, that's going to be our perimeter. 2,400 is equal to 2L plus W. Now, since we want to figure out what L and W are, I don't really want to work with the perimeter. I want to work with the area. Okay, that's what we want. We want area equals length times width. Well, since I have 2 variables, I can't quite take the derivative of it without having only 1 variable. So let's go ahead and solve for 1 variable. So I'm going to subtract by 2L to both sides. Then I'm going to have W is equal to 2,400 minus 2L. Now that I have this equation, I can go ahead and plug it into here. So I know that the area is equal to the length, which I don't know what it is, times the width, which is 2,400 minus 2L. I can distribute this. Area is equal to 2,400 L minus 2L squared. At this point, since I want to find the largest area, that's a keyword for the derivative. So I'm going to take the derivative of A. So I have A prime is equal to the derivative of 2,400L is just 2,400. And then the derivative of 2L squared is going to be 4L. Okay, now when I want to maximize something, I'm just going to set this equal to 0, and I'm going to solve for the value of L. So I'm going to minus 2,400 to both sides. Okay, oops. Minus 4L is equal to negative 2,400. And then I'm going to divide by negative 4. So I will find my first dimension, my first L, and this is just going to be equal to 600. Okay, and in this case, it's going to be feet. So I just figured out what my first dimension is. Now I need to figure out my W. Well, I can just plug it back into my equation. Okay, so I know that W is equal to 2,400 minus 2 times 600. Okay, so now all I got to do is just put this in my calculator, or you can do this by hand, whatever you want to do. So I'm gonna get, believe it's 1,200 feet. Okay, so in order for me to find my largest area, I require that I have my length be 600 and my width be 1,200. Okay, in the next video, I will go ahead and do this next problem, which is the one where you want to maximize profit.